Alright, today we're going to learn my favorite method on how to solve quadratics, and that's called completing the square. This is, like I just said, it's a method to use to solve quadratics, and this is an alternate to the quadratic formula. What's nice about completing the square is you don't have a formula to memorize. However, there is a procedure to memorize. So in order to complete the square, let's start with the quadratic in standard form. Say we have x squared plus 4x minus 8 equals 0. Notice how this is already in standard form. If it weren't, I would have had to do some algebra to put the exponents in descending order and the entire equation equal to 0. So now, in order to complete the square, you have to do a little side work. Take b, which is 4, and divide it by 2. And you get 2. I'm going to circle that number because I'm going to have to recall that number. This is my factor. Square it, and you get 4. This is the number we're going to add and subtract. So this is all the side work you need to do in order to complete the square. So there's two numbers we have to remember here. The number that we got as soon as we divided by 2, and a number we got after we squared. So now after I find out which number to add and subtract, I'm going to put that directly after the x term. So I'm going to have x squared plus 4x plus 4 minus 4 minus 8 equals 0. So if you take a look, is plus 4 minus 4 is really 0. So by adding it and subtracting it, I really didn't do anything here. I still have x squared plus 4x minus 8 equals 0. I just made it look a little different. And now this is why it's called complete the square, because I have a factorable trinomial here. And it is a perfect square trinomial, in which the factor is x plus 2 and x plus 2. Not a coincidence that this is the number that is in my factor. So if I factor x squared plus 4x plus 4, I get x plus 2 squared. And now I'll combine like terms here. I have negative 4 and negative 8. That is minus 12 equals 0. So let's add 12 to both sides. And take the square root of both sides. Don't forget, a square root can be positive or negative. Now we'll subtract 2 from both sides. And I'll express 12 as 4 times 3, in which 4 is a perfect square. So here are my two solutions. Negative 2 plus 2 radical 3, and negative 2 minus 2 radical 3. And in my opinion, that was a whole lot more efficient than using the quadratic formula. So let's just summarize some steps here. Step 1, standard form. Step 2, take b and divide by 2. Remember that this is your factor. Step 3, square the result from step 2, and this is the number you add and subtract. It is very important to add first, because if we're looking for a perfect square trinomial and that were negative, well then we wouldn't have the same sign between x plus 2 and x plus 2. The only way you can multiply this last number together and get a positive number is if those numbers are the same sign. Step 4. Factor trinomial. Step 5. Combine like terms. And square root of both sides. Don't forget, positive and negative values for the square root. That's why you end up with two solutions. So here are pretty much your steps to complete the square. Let's do another example. Again, this is already in standard form. I may have had to perform some algebra in order to get here, but we're practicing complete the square. Just don't forget you have to be in standard form before you complete the square. So we're going to take the b term, which is -4, and we're going to divide it by 2, giving us -2. Circle it because you're going to use that number again. That means I'm going to end up with a factor of x minus 2. Square it, and you get 4. This is the number you add and subtract. So we're going to end up with x squared minus 4x plus 4 minus 4 minus 10 equals 0. Again, this plus 4 minus 4 is really nothing. I'm adding 0 to that side of the equation. Because if I cancel these out, I end up with x squared minus 4x minus 10 equals 0. So really, nothing is going on here. So this yields a factorable trinomial. X squared minus 4x plus 4. Now I don't really have to think about factoring this thing, because when I divide by 2, that is my factor. X minus 2 squared, which is x minus 2 times x minus 2. Now when I combine like terms here, I end up with -14 equals 0. And now we could just clean it up and take the square root of both sides. X minus 2 squared equals 14. Take the square root of both sides. Positive, negative, radical 14. And add 2 to both sides. And here are my two solutions. 2 plus minus radical 14. If I want to separate them and say x1 is equal to 2 plus radical 14 and x2 equals 2 minus radical 14, that's the same thing. But this is just a much more concise way to express our solution. One more example, and that's if we have a leading coefficient of x squared. Let's say we had 2x squared plus 12x minus, let's say 6 equals 0. So now, if there is a leading coefficient of x squared, you must divide by that number. You have to have a leading coefficient of 1 in order to complete the square. So I'm going to divide each term by 2. X squared plus 6x minus 3 equals 0. I divided every single term by 2, including the other side of the equal sign. And now I can begin completing the square. In this case, we're going to take 6 and divide it by 2, giving us 3. Circle it because you're going to use it again. That will be your factor. Square it, and you get 9. This is the number you add and subtract. Add and subtract. Factor. So we're going to have x squared plus 6x. 9 is what we're going to add and subtract. Plus 9 minus 9. Don't forget that -3. Okay, there's our factorable trinomial, in which I don't even have to think about, because as soon as I divide by 2, that's my factor. X plus 3 squared. We add a -9 and a -3, which is -12, equals 0. Move that 12 over, and take the square root of both sides. Subtract 3 from both sides, and express 12 as 4 times 3, in which 4 is a perfect square. And here are my two solutions. X equals -3 plus 2 radical 3, and x equals -3 minus 2 radical 3.